Hey everybody, it's Brian. Just wanted to share the results of the first Moonlight experiment I did with the fish tank and two candles and a piece of plywood. Very simple, like I said yesterday, and it's pretty much what I thought. It was inconclusive. About 15-20 minutes into the candles burning, it got really windy, and the flames were just blowing all over the place, and that pretty much made them burn at the same rate. That's what was controlling the rate at which they were burning, in my opinion. And so I can hold them both here. You can see the bottom of them. Hold that even. They're about equal. I mean, there's no noticeable difference to draw any conclusion from. To do this right, I learned that you have to have the candles out of the breeze. The flame has to be still, especially if you're going to use a FLIR to try to read the temperature of the flame. If the flame's moving all over the place, you can't really do it. But it seems like you can do it if it's still. I was messing around with it a lot, and my neighbor and my roommate also witnessed some of the experiment. We had a little candlelight moon party, and they both agreed that the moon feels cold, especially when it started to come up over the trees. As I was working and getting ready, it felt like as the moon came over the trees, behind if you saw the video from yesterday, but behind the fish tank, it really started to cool the whole area off, and it seemed like that. But I'm starting to feel like I'm biased because I really like this theory a lot. It makes a lot of sense to me, and it feels right. Now, we're not supposed to feel things in science, we're supposed to use logic, but then I question, how do we know if something's logical? Because we have to know it feels right when all the pieces fit together, right? I don't know. Speculate that on that one all day long. But I feel like I'm a little biased, and so I had a neighbor and a roommate who said that their skin was telling them that the air felt cooler in the moonlight than it did in the shade. So let's just use that method to start with. If you don't have any candles or anything and you're interested in this, and the more people that feel the same thing, the more we can draw a conclusion and say, okay, moonlight's cold. Now, based on the experimenting I've done with the FLIR and playing around with it, in the moonlight, which I haven't been able to get a good recording of because it's so dark, but I got an idea on how to do this. I'm always finding that the temperature of the ground in the moonlight is colder. It's always colder. So I'm up there and being convinced that the moon is cold, but like I said, I'm a little biased because I like it. And that's the problem in science, is people start to like things and they want to make them work, and I don't want to fall into that trap, so I need help. And what I was going to say with the FLIR was, what I'm thinking is, if the clouds will give me a break today, I might be able to do this. I want to record doing the temperature, the difference in temperature between being in the sunlight and being in the shade of the sunlight on camera, so you can see the area that I'm doing it in, and then I'll come back and do it at night, and so you'll be able to see the same general area and know where the light is shaded, because very conveniently the sun and the moon both move through basically the same path in the sky. So when the sun and the moon are to the west, which is where I like to be when I do this, you can see that you can tell from the sunlight and the daylight portion that the moonlight's in relatively the same place. So you should be able to show the temperature difference on the FLIR going up in the sunlight and down in the moonlight. That's the idea. So I learned a lot from this experiment. Wasn't successful, but another thing I wanted to point out is I actually didn't have this piece of plywood over the tank. I had it standing up, but I can't really draw that here. It was standing up vertically, and the moon was more like here, so it was blocking it the whole time, so the airflow into the tank was even, roughly even. But I've really got to upgrade this tank and try to find a way to keep the flames protected. So yep, experiment 1, learned a lot, not really expecting much. Hope nobody had their hopes up too much, because I really didn't. I was trying to emphasize that yesterday. So let's keep going. If you can do this inside your house, if you've got a window that faces the east, or wherever there's a long period of moonlight coming in through the window, please do this experiment. I don't have that luxury, so I've got to go outside. But if you can put a candle out behind a wall, or 2 candles, use a control. I didn't do that either because I just wanted to see what would happen. But put 2 candles in the moonlight, 2 behind a wall, then and then just let them burn for an hour, 2 hours, and see if there's any noticeable difference. One guy commented about weighing the candles instead of measuring, where he weighed his candles and said that he found that the ones in the Moonlight were weighed less, which is actually better than measuring them. So that's another idea out there. The more we work together on this, the more we come up with ideas, the more we can come up with what I'm trying to do is find a very simple experiment to show both cold moonlight and an effect on fire. The effect on fire, I think, is also very interesting. That's why I want to find out if it's real or not. If the temperature change isn't that great, we might not really see anything. But till then, I'll keep thinking about experiments here and messing around with the FLIR to try to get some more video up there showing cold moonlight, because that's the idea. And until next time, peace.